Hey there, mathletes. This will be our last section in chapter 2. So we're going to end with infinite limits. So this section, we're looking at limits where the function increases or decreases without bounds. So typically it has the function has a vertical asymptote in there that is affecting the behavior of the function because it's either hugging the vertical asymptote going up or hugging it going down. Okay, so f is a function that's defined at every real number in some open interval containing c, except possibly it's c itself. So the statement, the limit of f of x as x approaches c is equal to infinity, means that f of x increases without bound. So similarly, the statement, the same limit, but if it equals negative infinity, that means that f of x decreases without bound. So again, this is going to talk about what I mentioned before in the earlier videos in 2.4. The equal sign in either infinity or negative infinity does not mean that the limit exists. On the contrary, it tells you how the limit does not exist by denoting the unbounded behavior of f of x as x approaches c. These are still technically DNEs, but it's saying how they are a DNE. It's answering the question, well, what's happening? So they're not values. Infinity is not a value. So if it's not, if the function is not approaching a value, then the limit does not exist. All right. So example 1, evaluate each limit. So this one I'm going to use the graph again. So it has a vertical asymptote at 1, and the graph looks like that. So from the left side, it's shooting all the way down towards negative infinity. Now over on the right side, for part B, your graph is increasing without bound on that side, so it equals a positive infinity. All right, part C, this one, like, you can't plug in the 1 and you can't really factor it into a way that's useful. So we're going to actually divide this out, and you can either use synthetic division or long division. Personally, I like synthetic, but if you want to use long division, that's you know, it's totally fine. So synthetic division, you know, 1 makes the denominator 0, so that goes in the box. On the top, we'll list out our coefficients. I'm missing the constant, so that's why you get a 0. And then just run through the division. So drop the 1. 1 times 1 is 1, so that goes in this spot. Negative 3 plus 1 is negative 2. And then it just keeps repeating over and over and over again. So negative 2 times 1 is negative 2. 0 minus 2 is negative 2. So now you've divided. So the top, it was an x squared, so the answer always starts with 1 degree less. And these are the coefficients of your answer. So it'll be 1x minus 2, and then the last number here is your remainder. So it goes over what you were dividing. So this graph, it has a vertical asymptote at 1, but it also has a slant asymptote at the x minus 2, which would be something kind of like that. And then the curve goes just like this. All right, so as x approaches 1 from the left, you're tracing along like this, and it's going up to positive infinity. For part D, the limit from the right that's going down towards negative infinity. Now, for C and D, the exercise is really just being able to use the graph. In calculus, it does come up sometimes where you do have to use synthetic division. So yes, you are kind of expected to know how to divide. Chances are I'm probably not going to give you one exactly like this on the exam or the quiz where you have to use it, but that's just me. I cannot speak for any other professor you might encounter, but you're expected to know how to do this when you get into calculus, just FYI. All right, so let's stop the video here, and we'll continue on and do, I think, probably the rest of it in the next video.